Alright, hey guys, this video is going to be about something called a reflection. And in geometry, when we reflect, we're talking about a movement on a graph. And so we call this, it's a special type of movement. It's called a rigid transformation. Rigid transformation. And I'll kind of explain here in a second. So it's a rigid transformation because it's called rigid because the object itself that we're going to move around doesn't change its shape or size. It's going to stay the same. So if we're dealing with a triangle or a quadrilateral or a pentagon, that shape's going to stay the same. It's going to move, but it's not going to change its size. So it's rigid. It stays the same shape and size. Same shape, same size. And it's a transformation because we're transforming it in the sense that we are moving it to a new location. So when we're talking about this type of transformation, we're talking about moving it around. Moving. And there are different types of rigid transformations. There's actually three major ones that we kind of study in our class. And reflect is one of them. So when we think of reflection, we're going to have a hand signal that goes with it here in a second. So let's try a problem. I have a graph all set up. You can pause the video and write all this down if you need to, but we're going to plot 3 points on our graph, and we're going to call them A, B, C. So A is going to be at 4 and 2. So we're going to go to the center, go over to 4, up to 2, plot the point and label it A. And then we're going to graph point B at -4, 2. So opposite direction, -4, up 2. There we go. Call that B. And then for part C, we're going to have, or point C, we're going to have a point at 1, 4. So 1, 4, so like right up here. C. And so we have a triangle made up of those 3 points. What I'm going to do is I'm going to use my ruler, and I'm going to connect those 3 points real quickly here, and make my triangle ABC, which should be easy enough to do. All right. So here's my triangle. We're gonna reflect this triangle. So this is what I call my original shape. It's my starting shape. And what I'm gonna do with my points here is I'm gonna label them as my original points. It's basically, these are the points that I'm starting with. But we're going to reflect it and we're going to find some new points. So the new points get a new name. It's still gonna be ABC, A, B, and C. But because we're going to be moving them around, we're going to call it A prime, B prime, and C prime. We use this little superscript symbol. Basically, it looks like a little 1 or like a tally mark that's real small, up high, and it tells the reader that, hey, it's the same point, but it's been changed. It's been moved around. It's kind of like we're going to move A and make it the new A, so we call it A prime, and we're going to figure out where is that located on the graph. Now we can't even do any of this without some directions. There's no directions yet in this problem. So here we have a triangle. We've plotted the point. We know we're going to go look for a new one, but what are the directions? So here's the directions for this problem. We're going to say reflect triangle ABC. Reflect triangle, there's my triangle symbol, ABC, over the x-axis. Reflect triangle ABC over the x-axis. So here's what that means. The x-axis is located here. It's the axis going left to right. It's horizontal. And we want to reflect it over. Now remember what reflection means. If you look in the mirror and you see your reflection, it's like yourself looking back at you. So to reflect a shape, what it means is to flip it over that axis. Take it from up here and flip it over the x-axis this direction, basically. And the way that works is it's kind of like folding your paper. If you were to take this piece of paper and literally fold it over on the x-axis, that would be your new shape. And sometimes that's kind of hard to show in a video lesson, so I was going to try showing you this way. If I put a little piece of paper inside this triangle, just a little piece of paper cut out to fit the triangle, a reflection would be to take that piece of paper, turn it over, and flip it over the x-axis. So literally grab that piece of paper, that triangle, flip it over and put it on this side, the total opposite side. So it's going to look something like that. And so what we got to do is we got to find those new points. So it looks like if I flip this thing over, the new A, remember this was A, it's still in this corner, but now it's at 4, -2. It's down here. So what I'm going to do is I'm going to mark that off as A prime. That's at 4 and -2 because I reflected over the x-axis. And my B, let's see, where's B at now? Well, B was here, and now it's here. So it's still at -4, but now it's down at -2. So B prime is now at -4, -2. And then C looks like it's moved from 1, 4 to 1, -4. It's just flipped to the other side, so I'm going to write that here, 1, -4. And I'm going to plot these on here. There's A prime, 1, -4. There's C prime. I forgot to graph that. And -4, 2 is B prime. And so that new triangle, which I'm going to connect, I'll use a different color here. The new triangle looks like this. There's our new shape. And we call this a reflection because, well, it looks like a reflection. It's kind of common sense almost for that word for us. But thinking about it is in terms of an axis, here's the x-axis where my marker is. We literally flipped it over the x-axis, so it's on the total opposite side. Like I said, it's basically like folding your paper. If you take your paper and fold it along your x-axis, and you do a perfect fold, it might be hard to see in my camera, but that triangle on top should fold right down on top of the triangle on bottom. And so we label our work like this. We show the original points, we show the new points, we write prime symbols, A prime, B prime, C prime, and then if we can, we try to write a rule for this transformation. So that's kind of my last step here is what is the rule for this transformation? And so looking at the points, each point has an X number and a Y number. And what happens when we reflected it? What happens to that X and that Y number? So look at A. X was 4, Y was 2. Now X is 4 and Y is -2. Or look at B. X was -4, Y was 2. B prime is X is -4, Y is -2. You kind of see what's happening here? The X's are actually not changing. The X's are staying the same. It's 4 and 4. -4, -4, 1, 1. There was no change to the x-axis, or x-coordinates. There are changes to the y's though. Look what happens. They change signs. The 2 became a -2. So we're going to say that the rule is to change the sign, change y to a -y. The little negative symbol flips the sign. And that is the rule for our rigid transformation, for reflection. So let's try a different one. That was kind of a overarching problem, just to kind of show you the basics here. But let's just try one of these with a brand new triangle here. But let's take this next problem and let's change the directions to reflect over the y-axis. So reflect triangle ABC over the y-axis to change it up. And if you'd like, you could probably pause the video and try the whole problem first, see if you got the hang of this before I do it. I'm just going to go through it. So A is at -3, 2. So I go to -3 and 2, and I mark it and label it A. B is at -3, 3, -3, -3. So down here, there's B. And C is at -5, -1. So that's going to be, here's -5, way out here, -1. That's going to be like right here. So we are looking at a triangle that connects A to B, B to C, C back to A. We're looking at this thing. This triangle is our original shape. Okay, so why don't we label that? Why don't we put that up here? This is the original triangle. And we want to find the new triangle. I just want to have some good labels here. So we're going to find 3 new points, and we're going to rename them A prime, B prime, and C prime. So we can figure out where those are located. So A prime, B prime, and C prime are going to come from taking this triangle and reflecting it over, what does it say, the y-axis. We're going to reflect it over the y-axis. So here's the y-axis. Is the axis going up and down? So if I want to put my pencil right there on the y-axis, now I got to imagine taking this triangle, flipping it over to the opposite side. So folding my paper. If you want, you can fold your paper in half to figure it out. I cut out a little piece of paper I can stick on top of this triangle. Picture there's that triangle. I'm going to pick that paper up. You probably can't see with my hand there, but I'm going to pick that paper up, flip it over to the other side. And on the other side, it's going to be the exact opposite, basically. Moving over to here. So totally on the opposite side. So the way I do this mathematically, if I don't have like little pieces of paper cut out, or I'm not really into folding my paper every single time, is I look at the y-axis and I kind of look at the distance across, like, okay, 1, 2, 3 units across. A is 3 units to the left. Well, if I flip it, A is now going to be 1, 2, 3 units to the right. There's A prime. Just on the opposite side of the y-axis because I'm flipping over the y-axis. So like C here is 1, 2, 3, 4, 5 units to the left. So now I'm going to go back here and go 1, 2, 3, 4, 5 units to the right. That's my C prime. B is 1, 2, 3 units left. So now I'm going to go 1, 2, 3 units right. There's B prime. And that's going to make up my new triangles. Here's my reflected triangle. And so I list out my points. A prime is now at a new location. It's now at 3 and 2. So 3, 2. B prime is now at 3 and looks like -3. And C prime is now all the way out here at 5 and -1. And those make up my new points. Now to take this to the level 4, to take this to a little bit more of an advanced level, I should be able to write a rule. So my rule for the points is the x and y values are changing. And how are they changing? Well, look at the numbers. So kind of study the numbers. The x's, let's see, it was a -3, a -3, and a -5. Over here it's a +3, a +3, a +5. So it is the x's that are changing. The x's are changing signs. So I'm going to put a -x here to represent that. The y's, let's see, the y's were 2, -3, -1. Over here it's 2, -3, -1. The y's are not changing in this problem because we flipped over the y-axis. So y stays the same. So my rule is the xy's change to a -x and still a regular y. And that makes up my, my work for this problem. So big idea. 1, you want to know how to do a reflection, how to look at the axis and count left and count right to sketch it. You want to label your points and make sure you use that little prime symbol to show people that that's the new shape. And then you want to remember that this is called a rigid transformation. That's an important word actually in geometry. It's rigid because this triangle and this triangle, they're still the same shape, they're still the same size, they still have the same angle measurements, the same side lengths. Nothing, I haven't changed the triangle in any way other than I moved it to a different location. I reflected it over. So in class, sometimes we always go like this when we say the word reflect because it helps us remember that, oh, it's like picking it up, folding it over, either the x or the y-axis. Okay, so that was a quick review of how to do a reflection. Hope that helps. Thanks. Bye.